Over here is this Mercedes. These are C-Class, a 205 model. So the client was complaining that the car is overheating, and we've narrowed down the issue to a faulty coolant pump, which is stuck. Even if you spin it with your hand, it can't spin. So let me show you among the steps that we took to narrow that issue down. So on the first thing, so there was no faults. So, and if we come to actuations and you come to the coolant pump, so when you activate the coolant pump, so over here, there's no actuation. This is the power that is being drawn by the vehicle. When you actuate it, this should change. Sure. So let us actuate it and see how much it changes, because it should change with more than 25 amperes. So the pump is actuated, as you can see, and you can see also the amperes have started rising to around 35, 34. So that means that the pump is running, and the pump is drawing current from the vehicle, which means the pump is okay. So as of now, so before, initially when you activate it, this would change, but nothing would change here. But right now you can see this changes to 92, and this follows, and now you can also hear that the pump is audible. That was not happening previously. So let me show you now the second test. So if you come here under tests and you scroll down to, let's look for it. So it should be around so here it is, electric coolant pump. So this is the pump, and this is where it's located on the engine. So as you can see right over there. So this is how the diagram, the graph is supposed to behave. You should let the car warm up to around like 70 degrees Celsius. Then when you command the pump, the temperature should drop. So let's see that practically. So let's continue. So let us warm up the vehicle a bit so that it can be greater than 55 degrees. Then I'll take it from there. So right now the temperature is around 70 something, headed to 80. So you see, when you actuate the coolant pump, the temperature should start dropping, because now the circulation, and so we should expect this bar to start dropping. So right now it's around 80. So let us activate it and watch how the graph behaves. So right there, it's activated. So let's give it a minute and observe how it starts. Have a look now. So you can see already cooling is taking place, and you can see that the graph has dropped, which means that the pump is now circulating coolant on the system, and cooling is taking place. Like you can see that peak all the way from 80 degrees, and it has come all the way like to around 65, and you can see it's still cooling. So also you can compare it. You see like what we had seen here before, this pulse image. This is how it should behave. It should warm up, and once it's warm, it should start dropping. So this is how the bar is expected to behave. So as you can see right now, that is exactly what has happened. So we can conclude and say our diagnosis was okay, and the coolant pump was the issue. So the car is okay. So we've replaced the coolant pump, and we've performed a vacuum bleeding. So as you can see over here, that is a vacuum bleeder unit, where now you apply vacuum to the system and suck the fluid inside to make sure that the car is okay, that there's no air leak on the system. So with this car, the issue is sorted. The car can be delivered back to the client, and it's a success on this one as well. So you can see the pulse image here versus what was there before. So we can conclude and say that the issue is okay. So the car is okay as of now.